Graphing multiple angle polar graphs is challenging because now you have more lines of symmetry than with the single angle graphs. So what you have to do is actually graph the trig function and determine where the lines of symmetry are. So what I did is I looked at y equals sine 3 theta and figured out where the symmetry lines are. Notice I did the period 2 pi over 3, found out the units by 2 pi over 3 times 1/4, and plotted those out. And I see that the lines of symmetry are going to be right at pi over 6 and also at 3 pi over 6, which is pi over 2. So pi over 6 is going to look like this, and it's going to be on both sides of that. And pi over 2 is the other one, which is going to look like this. And so I have a sense that it's also going to be at 5 pi over 6. If you were to continue that, 5 pi over 6 would be the next one. And so you also know that you're going to have symmetry here. So there's quite a bit of symmetry going on here. Let's go ahead and find some points. You have your theta, and it's really important here to pick the right thetas to get a decent R. And so watch this carefully when I do this. I know 0 is going to work. When I put 0 in, I get sine of 0, and that's 0, so that's 0 and R is 0. Then the other point I want is what makes pi over 6 here? In other words, 3 theta is equal to pi over 6, therefore theta is equal to pi over 18. And for my theta, because when I multiply that by 3, I get pi over 6. And so that's the sine of 3 pi over 18 and 4 times that. So that means that sine of pi over 6 is 1/2 times 4 is going to equal 2. 1/2 times 4 is 2. That means that pi over 18, which is here, I'm going to have a point that looks like this right here. Well, what would be the next point? It would be at pi over 2. So when does 3 theta equal pi over 2? When theta is equal to pi over 18. Pi over 2. So that's when theta equals pi over 6. So my next point is pi over 6 for sine 3 times pi over 6, which is pi over 2. And if I looked at the sine graph, that would equal 1, so this is going to equal 4. At pi over 6, it's equal to 4, which means really it looks like this. Now, with knowing that there's symmetry over this line, I can actually go ahead and put in the other part to this, which is that right there. So it's like a petal that's coming out of that particular one. Now let's keep going with a few more points. Pi over, let's see. So let me also see what pi would be. So this would be pi over 3. And let's see, 4 times the sine of pi over 3. 3 times sine is equal to 0. So at pi over 3, it's going to equal 0. Okay, that didn't show me too much. What about a different point? How about where your theta equals pi over 2 to see what that looks like? So I'm just going to go pi over 2. I'm thinking differently now. Instead of thinking what is my next number here, I just want to know what's going on that axis. So 4 sine of 3 pi over 2. Let's see. Sine of 3 pi over 2, if I think about that, it's going to be, let's see, normal. If I did a normal graph here, it's going to be that point, -1. So that's -4, meaning at pi over 2, it's a -4. 1, 2, 3, 4. So that's going to come back down like that. So a couple things that I'm going to note is that I do have a reflection, and so this reflection, I bet at 5 pi over 6, this point is going to be at 4 as well. 1, 2, 3. I'm assuming that this point right there is going to be a point because it's going to reflect over that axis. Let's just try one more point here and see what happens. 5 pi over 6, 4 sine 3 times 5 pi over 6, which is the same thing as 5 pi over 2, which is 2.5 pi. So that means that I would be at this point right here, which is just 1. So 4 times 1 is 4. And yes, it does come up like this. So what this is going to look like is going to be a graph with these petals. And I know that this petal makes sense because of the reflection here. And I knew that this would also make sense because there's a point here. And there's got to be some sort of symmetry around that line. That's without doing too many points, 6 points, I could get a real good idea of what that graph would look like. Now, if I were to look at this next graph, I would do the same thing. I would draw in the cosine graph. I would find out the lines of symmetry, and then I would reflect, trying to use the minimum number of points. Notice the points that I select are crucial in finding out nice whole numbers for my r's. Spend your time, really take your time on doing these. Be careful on these points if they're positive or negative. Also, be careful graphing them. Easy to make a mistake on this section.